So here we are. I would also like to welcome all the other partners from our group. So we are a group of different FP7 projects which are ongoing, and we share common goals. And we would like to present today some of our ideas. We would also like to present the impact which we have achieved so far. Many thanks to the Commission and also to the organizers of that event to give us the opportunity and the space to present our ideas. And yeah, so welcome. What have we planned for today? So we start with an introduction of the topic so that we know what we're talking about. Then we have our group presentation. We start with an overview about the group, and then we will complement this by a project rally where the different coordinators will present their project in a quick and catchy fashion. Two projects will be presented in more detail in form of a success story. This is the Symposium project and the Vistra project. And after that, we would like to summarize shortly the results from the FOF Impact Workshop, which took place in Brussels in March. And there are two topics which are interesting in terms of the results. This is the cross-collaboration issues, what has been done in terms of cross-collaboration and what is intended to do there. And we will also show the impact, and we would like to discuss on the future impact. Then we will lead over into the interactive discussion part, where we would like to encourage you to actively participate. If you have questions in between, just raise your arm, and we also try to interact with you and we try to answer the questions immediately. Let's talk about PLM. PLM is the cornerstone of the information structure of all the manufacturing enterprises, and it's the process of managing the entire product life cycle from the conception of the product via manufacturing to service and scope of the project. And in each of these phases, different information and data is produced, is consumed, and the challenge is to make that flow of the data and information seamlessly, and make this flow of data seamless. And that is what the PLM is about. If we narrow it down to the factory, then there's the concept of the digital factory, and I would like to mention that specifically because I think that is a very nice concept that consists of methods, tools, and models which help to plan, implement, and also to optimize and run factories. Which brings us then down on the lowest level, where we see all these different tools, CAD tools, CAE tools, computer-aided production planning, and also other tools. Now we have the big picture of what is our group about. So on the horizontal, it's about creating interoperability across the PLM, but it's also about improving the simulation tools in terms of accuracy, reliability, speed, maybe also to develop new tools and new applications. And also the European Commission has recognized this need, and as Dr. Riemschneider has said before, there were in the former FP7 roadmap 3 topics. One of them was the digital factory, the other two are smart factories and virtual factories. We will talk about this later on, but we represent the group of digital factories, and this comprises 8 projects. So the goals which were formalized by the Commission were European leadership. European leadership, that sounds great. In knowledge-driven platforms, tools, methodologies for product development and manufacturing. Second, accelerate product design, manufacturing planning, and better accuracy, reliability, and speed of simulation. That's pretty much what we showed in the beginning. This can also be illustrated by if we see the effort which it takes to bring a product into manufacturing. And basically we have two worlds. We have product engineering and we have manufacturing. And these both worlds, sometimes they do not work so well together because manufacturing is more traditional. They like to implement processes, and once the process is implemented, they don't want to change it. And the product developers, they're much more innovative. They are used to invent something new. how to bring the both worlds together. This is a simultaneous engineering challenge, and one way to do that is by early testing and optimization already in the phases of product development, and this allows us to have a smoother ramp up during manufacturing. So our topic is about bringing two worlds together, manufacturing and product engineering. That was the goal in the FP7 project, FP7 program, but we're moving on forward to Horizon 2020. We have seen something about Horizon 2020 before. It's, I think, the biggest research program ever. The question is, what will change in between? So the different megatrends, the challenges which exist, like globalization, changing customer demands, rapid technological developments, they still are ongoing. So they didn't change. So should we change our goals? That is one of the questions. Maybe we can answer that. But we started also to collect some key points. They basically come from the Commission, and they could be the goals for the future Horizon 2020 roadmap. And there it said, responding to higher variance, shorter innovation cycles of highly complex products like cars and airplanes. I tried to translate that, and for me that's basically about mastering complexity and increase transparency. Then boosting the launch of innovative products through digital design and validation. Okay, we have to stimulate new innovations in terms of products, but also in terms of tools which are used to design these products. Then we want to shorten the production, or the time to production, that we just have seen before. We want to improve productivity, reduce effort, time, and costs in production. The second last bullet point is about modeling, reuse, and sharing of manufacturing knowledge. So this is interoperability. That's a big issue. How can we achieve interoperability through semantics maybe? But if we create it through semantics, what's about the quality of the data? How can we cope with consistency and completeness of the data, for example? And the final bullet point about enhancing innovations through new design tools. So we need to develop new applications, and existing applications, they need better usability. So we have to create intuitive tools. We have to bring the different applications on the shop floor. We need mobile applications, context-sensitive applications, and collaborative applications. So if we take these bullet points, I tried now to locate them in a pyramid. And I would say the new applications and the interoperability and usability issues, they are the basic thing which we have to establish. Through better applications and interoperability, we can achieve to master complexity and to increase transparency, and that finally will then lead to improved productivity and reduced efforts and costs in production. One example which nicely illustrates how Horizon 2020 in terms of the digital factory can be implemented is the Cloud4 project, which is currently under negotiations. But the idea is very interesting because it's about bringing different ICT tools into the cloud and also establishing interoperability between that different ICT tools. The good thing is the SME service provider, they can provide a bigger package. They can provide more solutions by joining up with other SME service providers, and they can offer their services by use, and we do not have to buy the product when we want to use it. So by bringing this ICT tools into the cloud, we could also address new end users, new SMEs, which can take up the technology and use that to design their products and production processes. So that is all for the thematic overview, and I will hand over to Nikos now for the overview about the group.
Good morning, ladies and gentlemen. I'm Dr. Nikos Patras from the University of Patras, and I will give you a brief overview about a group of projects that this class is dealing with. So the projects that we are presenting today are Vistra, Know4Car, Arun, Terrific, amePLM, ENEPLAN, Symposium, and FP. These are different projects dealing with different objectives, different problems, but we also share some common objectives, some complementary objectives. For instance, the first objective is to achieve interoperability in PLM. Another objective is to introduce semantic technologies. Another one is to use virtual reality and augmented reality techniques and technologies. Simulation is very important for these projects. We also have multi-agent systems and how we can introduce these kind of systems in manufacturing environments. And we also have other objectives that are related to engineering and manufacturing issues. We're dealing with a number of different use cases from different industrial sectors. For instance, the Vistra project deals with problems met in the automotive industry. The major goal there is to introduce virtual training in order to reduce the need for physical training in product assembly. The Know4Car project is also dealing with problems met in the automotive industry. And the major objective there is to introduce an efficient knowledge-based platform for capturing, organizing, and reusing manufacturing process knowledge. The amePLM, on the other hand, deals with problems that emanate from the electronics, automotive, and medical devices industries. And the major objective there is to introduce semantics technologies in order to minimize the efforts for information transfer and retrieval in engineering. Then we have the Terrific project with industrial use cases from the automotive, railway, aircraft, and machining tools industrial sectors. The major goal there is to achieve a better interoperability of CAD systems and finite element analysis, computational and fluid dynamic systems through the introduction of isogeometric technologies. Then we have the Symposium project dealing with use cases from the steel production industry. The major objective there is to introduce interoperable simulation tools for non-destructive testing and material characterization. We have the FP project from an entirely different industrial sector, that is the textile and garment industrial sector. The major objective of this project is to introduce new business and production workflow for representing the whole development process. Then we have the Arun project with a specific case from the aerospace industry, and that is the wrap-up production of the A350 plane. The major objective there is to introduce novel agent-based system for achieving and distributing scheduling and to improve therefore the production wrap-up phase. And then we have the ENEPLAN project, which has use cases from three different industrial sectors, that is the aeronautics, the household, and the automotive industrial sectors. The major objective is to build a platform that will improve the energy efficiency of manufacturing processes. So the first objective, the interoperability in PLM, the objective here is to achieve seamless data management in a number of different phases, starting from the product planning and product design phase, and ending with the use of product and the service of product phase. The second major objective that this cluster of projects is dealing with is semantic technologies. The idea here is to introduce semantic technologies and to move from the standard way data is handled today, that is untyped information, little chance to process this information with computers. This is what the standard web technologies are doing right now, and to move to the semantic web technologies where information may be more extensible, can be relational, and of course it can be processed by computers in a much easier manner. Then we have the augmented reality and virtual reality technologies. In the past, we have achieved high immersion, but with high cost and low flexibility, especially with virtual reality technologies. On the other hand, desktop applications achieved low immersion on the one hand, but low cost on the other hand. And the major objective here is to achieve with augmented reality and virtual reality technologies high immersion, low cost, and high flexibility. How are we going to do that? going to use advanced user interaction, such as mobile interaction, gesture-based interaction, speech-based interaction, and of course advanced visualization techniques, haptic feedback, and serious gaming options for making it easier for the operators in the software, for instance, to get trained for a new manufacturing process. Simulation, finite element analysis, computational fluid dynamics. The major issue here is to try to model incompatible mathematical representations in a way that today's computer-aided systems can understand. And this is a major issue because although we have achieved to have novel mathematical representations, this cannot be used at the time being from all the commercial systems. Then another objective that we have in this field is to achieve, we have interoperable simulation tools for non-destructive testing and material characterizations. Finite element analysis tools, for instance, NDE tools, that is non-destructive evaluation, not near-death experience. Computational fluid dynamics, and so on, are some of the tools that we're going to use and develop in this field. Then it's the project writing. We have the projects, the 8 projects that are part of this field. The first project is a Know4Car project. It's not about guiding the consumer when he or she wants to buy a new car. It's not about learning how to drive. It's rather about building a knowledge-based platform that is able of capturing, organizing, and reusing information that's related to manufacturing processes. The major objective here is to build a web-enabled IT platform that will be capable of making it easier for different stakeholders, for instance, OEMs, system integrators, material suppliers, equipment suppliers, to work together to exchange knowledge. The Know4Car platform consists of 4 different components. The first component is about process knowledge management. This is about building a data model and the associated ontology for dealing with all information that is related to manufacturing processes. The second component is a developed collaborative platform, is the backbone of this platform. This is where all components will be linked together, will be integrated, and this is the main component that will give the chance to different companies, to different organizations to work together. We have the extended engineering component, where the major issue here is to allow different organizations to exchange information in a secure way. And of course, we have the advanced user interfaces and training component. This is about introducing modern augmented reality technologies to the software so that the operators may be trained in an easier and faster way. We have 2 major case studies in this project. The first is about the automotive assembly, and the major objective of this use case is to validate human-based assembly process to use augmented reality techniques for training the operators in the software. And the second one is the extended engineering collaboration, where OEMs, SMEs, system integrators, material and equipment suppliers can work together exchanging information, thus making the whole process faster and more cost efficient. The major results that we expect from this project is to enable the faster process design by 20% and to reduce the time required for identifying existing relevant knowledge and for organizing this knowledge and using the knowledge by 60%. The second project that we present in this cluster is the ENEPLAN project. The major objective of this project is to develop a netcode-based and web-enabled metacam tool in order to improve the energy efficiency for specific manufacturing processes. So the first objective that we have in this project is to reduce the environmental footprint for specific manufacturing processes, especially for metal form components, by selecting a more energy efficient combination of processes among the ones that are available in the supply chain. For instance, if 2 different suppliers and are able to carry out a specific bidding process, then from the energy efficiency perspective and from the cost perspective, one of these partners can do this job in a better way. Another objective is to improve the energy efficiency on the process level. The idea here is to optimize the process configuration, to optimize the process parameters from the energy and cost perspectives. On the other hand, the ENEPLAN platform will also take advantage of information that is related to the weather, in order, for instance, to check when energy coming from renewable resources is available. Also, this platform will be able to take into account information that comes from the market, that is, for instance, different demand partners, different orders coming from different partners, and at the same time, it will also take into account information coming from the shop floor of the partners that belong to the supply chain. So, in one picture, what we do here is that the end user will introduce the product, process, and resource specifications in the platforms at the high level, and then the ENEPLAN repository, consisting of a list of libraries and a series of advanced algorithms, will take into account these high-level specifications, and it will transform these specifications to low-level specifications, taking into account at the same time the demand profile, information that is related to weather forecast, and also information that is related to the status of the shop floor of the partners belonging to the same supply chain, and in the end, the output will be an optimized process plan. 3 different case studies will be realized in this project from three distinct industrial sectors. The first case comes from the household industry, and we will introduce the problem of producing 6 versions of 4 panels for refrigerator doors. And the idea there is to compare different manufacturing processes, for instance, punching or laser machining, from the energy and cost perspective. The second case comes from the aeronautics industry. It's a loading ramp hinge of a military aircraft. And here we are going to compare also different manufacturing processes, for instance, welded cutting and milling. And the last case is related to the automotive industry, is a seat frame. And what we are going to do there is we will compare different welding technologies, for instance, spot welding, arc welding, and laser welding from the energy and cost perspective. So that's all from my part. The next project is the ENEPLAN.
Hello together, my name is from Know4Car Stuttgart, and we're the coordinator of the project amePLM. So it's named Advanced Platform for Manufacturing, Engineering, and PLM. It should offer a new and extensible approach to collaborative engineering, leveraging semantics, heuristics, and visualization. Before we engineer an ontology that serves as an interoperable model and integrating element for an open engineering system, the amePLM platform. Right now, we're in the process with our industrial partners to refine the ontologies. And as you may know, forming an ontology is a very iterative process, so you have to go back and refine an ontology if it doesn't fit correctly. And right now, we're in this stage. So our goal is to develop an open engineering platform based on existing tools and libraries. We want to research and develop tools to assist in product and process development. And we want to devise a visualization module to enable cross-disciplinary collaboration to make this easier. And therefore also remote consultation approaches. You see here is a little picture of our architecture. So in the middle you see the amePLM engineering platform, and right around it you see the ontologies as a base element of the architectures. Here's a short slide about our partners. So you can see we have 13 different partners. Right now we're dealing with integrating our new partner USU because one of our main partners went bankrupt last year. And right now we're also talking with a new partner, Dassault Systems Exalead, who is also interested in our project. And if someone like Dassault Systems wants to cooperate with you, it shows that you're on the right way. And we're right now in the middle of our